So in this video, we'll be looking at stack as a data structure. So first, we'll be looking at what are some of the use cases where a stack might be used. Then we'll look stack as a data structure. So we'll look at what is the last in first out principle of the stack. Then we'll try to implement stacks using array with some of the common functions that are associated with the stack. So like push, pop, what is the stack top, whether the stack is empty or full, the size of the stack, and let's say displaying the elements of the stack. Hey friends, welcome back. If you are new here, my name is Vinay and I am a seasoned software engineer with over 10 years of professional experience, having worked at Amazon, Nvidia, and currently working full-time at Microsoft. I enjoy sharing my knowledge with a focus on understanding things at a fundamental level. I hope you learned something new today. Let's get into it. So starting with the use cases. So first, let's take a real world example. So now let's say you are using a word processor like Microsoft Word or a notepad. So there you typically sometimes do the undo action, right? So let's take a few examples. So let's say you wrote something in the word processor. Now what you want to do is you did some action like let's say deleting a line. Let's say delete line number 10. Okay. Then the second action you did on top of this was let's say again deleting line number 20. And then let's say the third action that you did was changing the font size. Okay, changing the font size let's say from 10 to 20. Okay, so now let's say you decide to undo these things, right? So as you noticed, the first action that we did was deleting line number 10, the second was deleting line number 20, and third was deleting or changing the font size from 10 to 20. So the actions that we did were added to a stack, you can say, in this way. So the first action that we did was added to stack at the bottom. The second action that we did was added after that. The third action that we did was added on top of the stack. Okay, so now let's say you do Control Z, which is typically an undo shortcut. Okay, so here what would you do? So when you do Control Z, what will happen is the top item that is there in this data structure. So you will remove that action. So in this case, what will happen? The font size which I have changed from 10 to 20 would change back from 20 to 10, right? And this action would get removed from here. Let's say you did Control Z one more time. So what will happen? So the second action that you did, that would also be undo. So whatever content was there in your line number 20, that will reappear. Okay, so then this is also gone. So then at the last, what would happen is, let's say you again did Control Z. So this action that you did, which was deleting line number 20, so that would be again brought back. So your line number 20 would appear again. So if you observe carefully now, so what happened was in this stack, the ordering that has happened was, so first the whatever action or whatever entry was there at top of this list, you can say, so that was undone. So the item at the top was 3, so that was undone, and then the item that was at entry number 2, that was undone, and then the item at entry number 1, that was undone. Okay, and when we look at the order in which the items were added to the stack, so it was from bottom to top. So first you had deleted line number 20, so that was added at the bottom. So second you deleted line number 20, so that was added after the first action, and at the last you had changed the font size, so that action was added at the last to the top of this list. Okay, so the ordering that we observed here was what? So you inserted whatever data item that you inserted at the last. So whatever data item that you had inserted last in this stack or in this data structure, that had come out first. So in a way we can say that whatever was my last thing, so whatever item that got last inside the data structure came to be the first one out of the data structure. Okay, So that is what we mean by last in, first out in short. Okay, so whatever item that we add to the data structure at the last comes out at the first from the data structure. Okay, so stack as a data structure operates on this principle, which is last in, first out. So the items in the stack are always added on top of the stack. So here when you first deleted line number 20 and after that let's say you deleted line number 20. So this action of deleting line number 20 was added on top of the first item, which was deleting line number 10. Okay, so you always add elements at the top of the stack. So that is the behavior of the stack data structure. So here what we saw was the stack data structure was typically used to support what? The undo operations in a word processor. So this is a real life example where you would be using stack as a data structure. So with that as the background, now let's get into the details of how each of these functions that we saw earlier, which was push, pop, top, empty or full, we would be implementing using the stack. So for an example, let's assume my stack is of size, let's say size 5. Okay, so typically I would draw a stack like this. So this is open from this end and this is closed from this end. So whatever additions you are doing, you have to do from the top. Whatever deletions you are doing, you have to do it from the top, right? So that is why a stack is typically drawn like this. Now assume that we have stack of size 5. So there are, let's say 1, 2, 3, 4 and 5 entries that I can fit into my stack. Okay, so the current state of the stack is empty, right? So this is what an empty stack looks like. So when we represent this stack as a data structure in my programming, so I could implement it using different ways. So one of the ways or common ways to implement a stack is using a array. So this is the most simple way to implement the stacks using arrays. So what do we mean by that? So let's say this, if I have stack of size 5, so this is entry number 0, 1, 2, 3 and 4. Okay, so array, my size of the array is what? 5. Now that I have an array of size 5 which is representing my stack, now I have to know at what locations in this array I can actually add or remove elements from. So to understand that or to know that, we keep a indicator which is called as top of the stack. Okay, so top denotes the position in this array where I can add the elements at or remove the elements from. Okay, so since initially my stack is empty, so I would point this top to, let's say, an index before this 0. Okay, so before this 0 means my top initially can be -1. Okay, so my first condition that I have, which is empty, how can I write it? So I can simply check if my top is equal to what? -1. So if it's -1, it means I can return true. So this is the case to understand that my stack is empty. So initially my value of top is -1. So what I would do is I will first increment my top by 1 and then add my element at that location. So let's say the element are added in, let's say, order like 10, 20, 30, 40 and 50. Okay, so the first element that I am adding is 10. So what I would do, my initially top is what? -1. I will increase my top by 1. So now top becomes what? 0, and at 0th location I would add this 10 element. Okay, so I would do this array, whatever is my name of the array of top currently would be what? My item that I want to add in the stack. Okay, so this 10 would get added here. Okay, so now after adding 10, now let's say I want to add 20. Okay, so now the value of top is what? 0. So after adding 10, my top is what? 0. Okay, so now let's say I want to add 20. So what I would do, I would again increment my top, which will change from 0 to 1, and then I'll add 20 at index 1. So this 20 here would be added at index 1. So similarly I'll keep on doing this. So my now top is 1. So top from 1 would change to 2. So top will become 2, and then I'll add the next element 30 to location 2. So here I would get added 30. So now my top value is 2. So what I would do is I'll first increment my top to 3, and then I'll add the next element at index 3. So what would happen is my top would currently be 3, and I'll add my number 40 at location 3. Again, what I'll do the same thing. My top will become from 3 to 4, and my 50 would get added at location 4. So this 50 would be added here. So now my top value is what? Top is equal to 4, right? So now when I try to add the next element, this is where it gets interesting. So now after adding 50, the value of my top is what? 4. So now let's say if I were to add 60. So in this case, what would happen? So my top is currently what? 4. So my top is equal to 4, and now I want to add 60. So what I'll do, my top would become what? 4 plus 1, which is 5. But my size is also equal to 5, right? So my top plus 1, if it's equal to size, then what I can say that is my stack is actually full. So whenever my top becomes equal to size minus 1, or if my top plus 1 is equal to size, that means my stack is full and I can no longer add elements to the stack. So that is what we mean by my stack is full. Now we'll continue with the same example and see what happens when we try to pop elements from this stack. So we'll take the same example where we have 10, 20, 30, 40 and 50. Okay, so these were my elements in the stack at index 0, 1, 2, 3, 4, right? And my top was what? Currently 4. Okay. So now let's look at the pop operation. So in pop operation, what do we do in pop operation? So the pop operation returns the element which is always at the top of the stack. So in this case, since my top is 4 and fourth element is 50, so my 50 should get returned. And whenever we call a pop operation, we first also have to check whether my stack is empty. So if my stack is empty, I don't pop anything. And as we know with stack, so last in is the first one to go out. So last in, first out. So here we can see that the 50 was the last element that went into stack and 50 would get popped. So what actually happens in the pop? So let's see. So let's say this is my current value of top. Okay, and this is the current element that I would return, and this is the modified value of top. So top modified value. Okay, so let's see what happens with this. So my current top value is what? 4. So what would happen? My current element is what? 50. And when I do a pop, what I would do, I would decrement this value of top by 1. Okay, so my modified top value would then be 4 minus 1, which is 3. Okay, so then this 50 is kind of removed from here, and my top now points to what? 3. So this is the modified value of top. So this is the first call to the pop operation. So in the second call, what would happen? My top is 3. My current would be 40, which is the element at array of top. Okay. So my top value was 3. So array of top, that means array of 3 is 40. So that is why this 40 is written here. And the modified value of top would be what? 3 minus 1, which is 2. Okay. So then this means that this top would go from here, this 40 would go from here, and this top would become what? Equal to 2. In the third iteration, what would happen is my current top value would be 2 and the current element would be 30 and my top modified value would be what? 2 minus 1, which is equal to 1, right? So this 30 would get removed from here, this top would now point to 1. Okay. And at the fourth iteration, again the same thing. My top value was 1, so array of top will be this 20 here, and then so this is 20, and then 1 minus 1, my top value will be 0. So this top and this 20 would get removed, and this top value will become what? 0. And in the fifth call, my top value is 0. My top value is 0, and then my current element would be array of 0, which is 10, and my top would become what? 0 minus 1, which is minus 1. So then again this top would be removed, this value will also be removed, and top will point to minus 1. Okay. Now again if I try to call pop operation, let's say, so since my top is already at minus 1 and my isEmpty check would return what? True. So I would no longer access elements from this array, and if you try to do that, you would get a segmentation fault. So that is how typically a pop operation from the array looks like. So now let's look at the two remaining functions, which was the size and the top function. So again let's take the same example of our stack. So this is 10, 20, 30, 40 and 50, and this is index 0, 1, 2, 3 and 4. Okay. Let's say this 50 was popped out from the stack. Okay. So there are only currently 4 elements in the stack. So this fourth element here is not there. Okay. So now my top would be pointing then to what? Top would be equal to 3. So now if I want to get the top element, what I should return? Whatever value is stored in this top variable. Okay. So similarly for the size, what should be the size of the stack? It should be equal to whatever is my value of top plus 1, because our indexing is starting from 0, right? So my size of the stack, so here I can just return what? Top plus 1, and if someone just calls the top, I can just return what? My array of top. So this is the element that would get returned. Okay. So these are the two functions that we saw. Further, if we look at the display function, okay, so display we would have to do from top to bottom. So what I would start from index value of top. So from top I will go until, let's say, my index I is at the top, and until I is greater than or equal to 0, and then I minus minus. What I can do is I can just print the value of array of I. So here printf, let's say, array of I. So we will, so first my top value would be, let's say, if it's 3, then my I will be what? 3, and array of 3 would be what? 40. So first 40 would get displayed, and then I minus minus, then from 3 I would come to 2, and then array of 2 is what? 30. So this 30 would then get displayed. So similarly we will display 20 and then 10, and after 0 I would become what? Minus 1, and then this condition here of the loop would get false and would no longer be printing elements. So this is how we would write the display function for a stack. Now let's look at the code. So in code we are taking a structure which defines our stack. So as we saw, we will have an array. So that array here is called items, and the max size is defined, which is 5 as we saw in our example, and my top is what we would get initialized. Okay, so I also wrote an initialize function here. So in the initialize function, my top would be what? Initialized with -1. So this is our case when my stack is actually empty. Okay. Then similarly for is empty, so is empty would be when my stack top is actually what? -1. So if my stack top is equal to -1, I just return. So if it's -1, it would return true, otherwise it would return false. Okay. Then if we come to is full, so if my stack top is equal to the size -1 as we saw, so this would mean that my stack is full. So if this condition is true, I would return true, otherwise I would return false. Similarly in push function, so as we discussed, so first we'll have to check whether my stack is full. So if we call this is full method, so if this is full method returns true, it means my stack is full, right? So if my stack is full, I just print an error like stack overflow. We cannot push whatever item we had to the stack, and we print the stack is full. Okay, and then we just return. We don't execute the below steps. Okay, if this condition is false, it won't go inside and we won't return from here, and then we would come to here. So when we are pushing, what we do, we increment our top by 1, and then we add the item, whatever item we want to add at this top location. So s of items means this items is this array here at line number 8. So in that array, at location of top, I add my item. So s of items at top location is equal to my item, and then I just print pushed this element to the stack, and which is the item that is passed to this function. Okay, so this is the push method. Next we look at the pop function. So in pop function, again we first check whether my stack is empty. If it's empty, we print an error like stack underflow, and we cannot pop from an empty stack, and we return -1 to indicate that the stack is empty. So if this condition was false, we won't go inside this if statement, and then we have to come down. So my popped item is what? The item that is currently at the location of top. So items is my array again in this struct stack. So whatever was my item at that top, so that is my currently item that would get popped. So popped item is that value, and then I decrement my top by 1, and I just print that this is the popped item from the stack, and I return whatever we had stored here. So this is how a pop function looks like. So now if you look at top, so what would the top element give us? So top element would give us the value which is there at the top of the stack. So again here I have to check whether my stack is empty and return and print an error. If not, I would return whatever is my item at the top of the stack. Okay, so this is the top element, and size is simply the value of top plus 1. And then for display, we first have to check whether my stack is empty. If it's not empty, then I print the elements from top to 0. So I print it in the reverse direction. That is how the stack order follows. And then in the main method, we'll just exercise all these functions. So first we'll initialize, and then we are pushing 5 elements from the stack. So we are pushing 5 elements to the stack. Then we are pushing one more element, and this is where we are expecting an error that the stack is full. So first let's try to execute this. So as we can see here, we pushed 10, 20, 30, 40, 50 to the stack, right? And then when we are trying to push 50, we get a stack overflow error saying that stack is full. Okay, and then we call the display method at line 92. So stack elements from top to bottom, what does it say? 50 to 10, right? And then what do we see? My current top element and current stack size. So current top element is 50 because this is at the top of the stack 50, and the size is 5 because there are elements from 10 to 50. Then again what we do, we pop 2 elements, right? So 50 would get popped first, and then 40 would get popped first, and popped after that. Then again we display the stack. So we display stack again from top to bottom. This time this 50 and 40 that were present earlier, we have already popped, and now what we can see is only 30, 20 and 10 are there in the stack. Okay. Then we print the current top element and the stack size. So current top element is 30, stack size is 3. and then again we pop 3 times. So all these 3 elements, which is 30, 20 and 10, so these are popped from the stack. And then again at the end, when we try to pop when the stack is empty, we get an error that stack underflow cannot pop from an empty stack, right? And at the end again, when we try to display, we get an error which is saying that the stack is empty. Okay. So this is how stack is implemented. Thanks for watching. In next videos, we'll look at some of the common problems that can be solved using stack as the data structure.